Okay, we'll take a few numericals related to whatever the topic I have covered. See the screen. There are two cells of EMF 2 volt and 1 volt have their internal resistance 1 ohm and 2 ohm respectively. Their positive terminals are joined by a wire of resistance 10 ohm and negative terminals are joined by a wire of resistance 4 ohm. Another wire of resistance 10 ohm is connected between the midpoints of these wires. Find the current through the cells and the potential difference across a 10 ohm resistor. I think the problem is clear to you. Now, this problem I am going to solve with the help of KCL and KVL. Look at the solution. Now, the solution for the problem. So, according to the problem, there are two cells. One cell is of EMF 2 volt, another cell of EMF 1 volt, and their internal resistance respectively they given as 1 ohm for the first cell, 2 ohm for the second cell. You can read the problem carefully, you will understand this. What else they said is, positive terminals of the cells are connected by a wire of resistance 10 ohm. Remember, this is a wire having a resistance of a 10 ohm. Negative terminals are connected by a wire of resistance 4 ohm. This is a wire of resistance 10 ohm, this is a wire of resistance 4 ohm, and the midpoint of those two wires are connected by a one more wire of resistance 10 ohm. Okay, now for a better understanding, let me represent the resistance of the wire in terms of a resistance symbol. The midpoint of these two wires are connected by a wire of resistance 10 ohm. I will represent as a resistor for a better understanding. This is of resistance 10 ohm. Since it is clearly mentioned that their midpoints are joined means, since this wire is of resistance 10 ohm, can I equally divide as 5 ohm for the upper part and 5 ohm for the lower part, right? Means here also I can say that there is a resistor of resistance 5 ohm. Here also I can say net resistance in this part as 5 ohm. Total resistance of the wire was 10 ohm. Here also this side, total it was 4 ohm. I can redraw it as 2 ohm for the upper part and 2 ohm for the lower part, correct? Why equally divide? Because it is clearly mentioned the midpoints are joined by another wire of resistance 10 ohm. Okay, now coming to the question, you are asked to find out what is the current through the cells and also current through a 10 ohm resistor and also potential drop across 10 ohm. So, what you can do is, for your convenience, you can name these corners A, B, C, D. Here you can name it as corner E, corner F. Try to identify how many branches are there in the circuit. 3. To find out how many branches are there, you have to stand at the junction or a node. Can I say B is a junction or a node? Start from that junction. How many paths you have? 3 paths, correct? Isn't it? So, 3 paths you have. So, there are 3 branches. When you say there are 3 branches, surely there will be 3 different current. So, shall I assume the current in the upper branch as I1, current in the lower branch as I2, current in the middle branch as I3? Next question is, what is the direction of a current? I already explained in the theory part, direction of a current is assigned arbitrarily. Of course, you have only 2 options. Current in this branch can be directed from B to C, C to D, D to A, or it can be directed from A to D, D to C, C to B. Any one direction you can select, your choice, because rule says like that. You have to select direction of a current arbitrarily. But I gave one suggestion to you. Of course, you need not follow the suggestion, you can stick on to the rule. Suggestion was, if there is a cell in the branch, you select that direction of a current as sent by the cell. Do you have a cell in this branch? Yes, there is a cell in this branch. So, normally cell will send a current from positive to negative. We will stick on to that. I said you need not follow this solution, you can follow your own direction of a current. You could have selected in opposite direction. Okay, I will select direction of I1 in this direction. It is from C to D here means, of course, idea was positive to negative. C to D means here also in this direction, here also in this direction. In a branch, current will be in the same direction and amount of current is also same, I1 only. Same thing I will do it for this part also. Here there is a, in this branch there is a cell, I will stick on to that. I said you need not follow the suggestion, you can select any direction of a current. Can I say this is I2? Positive to negative, that is the logic. This is I2, this is I2, this is I2. Same branch, no, current should be same. What you are left out with? One more. There is no cell, you select your own direction, not a problem, either from A to B or B to A. I will prefer A to B. Now the next question may be there in your mind. I cleared it during the theory discussion also. What if the direction of the current in the branch is not same as what we have taken? No problem. When you do the calculation, you will get the answer with the negative sign. Negative sign indicates that direction of a current in the branch is not as you indicated, it is opposite to it. You need not break your head, you need not go to change the direction. That negative sign you include in the calculation, that's all. Okay. Now, straight away we will go for the solution. Applying KCL to the node A. If you apply KCL to a node A, you know A is a node, even B is also a node. Sum of the current entering the node is equal to sum of the current leaving the node. Which are the current entering the node? Surely I1 and I2. Which is the current leaving the node? I3. I1 plus I2 is equal to I3. One of the question in the problem is, what is I1? I1 is a current through the cell. What is I2? Current through the cell. What is I3? Current through a 10 ohm. I1, I2 and I3 you have to find out. And not only that, you are asked to find out the potential difference across 10 ohm. Potential difference across 10 ohm is a product of current and the resistance. Resistance we already know, 10 ohm. What is the current through it? I3, which we don't know. That means to answer all the questions, I have to find out I1, I have to find out I2. Once I get the answer for I1 and I2, don't you think I can substitute here and I can find out I3? That is a procedure. Clear? To get I1 and I2, let me take a help of Kirchhoff's voltage law. You know, KVL is applied to a mesh. I am applying KVL to a mesh A, B, C, D, A. You know, the mesh can be selected in a clockwise direction or it can be selected in a anti-clockwise direction. So, in what direction you select a mesh, that is the direction of a traverse, it takes a very important role in giving a sign convention for product of IR and EMF. You already know it. So, I am applying KVL to a mesh A, B, C, D, A. I will go in the order A to B, product of IR, 10 into I3, right? Sign convention. If the direction of the current in the branch, if it is same as the direction of a traverse, then the product of IR is taken as a negative I3, and see, direction of a traverse is from A to B, I3 is also directed from A to B, so obviously product of IR is negative. Okay, A to B I reached. We will move from B to C. B to C, do you have any resistance? Obviously, there is a 2 ohm. What is the current? I1. So, it is 2 into I1, right? Plus 2 into I1 or minus 2 into I1? Again, it is minus, because direction of a traverse is from B to C. Conventional current in the branch is also in the same direction. So, product of IR is negative. Move from C to D. When you move from C to D, do you find any resistance? Yes, there is a 1 ohm internal resistance. What is the current through it? I1. So, product of current and resistance is 1 into I1 plus 1 into I1 or minus. Again, it is minus, because direction of a traverse is from C to D. Direction of a conventional current in the circuit is also C to D. Okay, I reached till D. Move, proceed further. You have to end up at A. From which point you started at the same point you should end. No. So, if you move from D to A, what is the resistance you come across? 5 ohm. What is the current? I1. So, product of current and resistance is again 5 into I1 plus 5 into I1 or minus 5 into I1. Again minus, because direction of a current in the branch is same as the direction of a traverse. So, it is obviously minus I1 into I1, minus 5 into I1. So, algebraic sum of IR is over. Then have to take up EMFs. We used to follow the same procedure. We will take up EMF. Again move from A to B. Do you have any cell? No. B to C? No cell. C to D? There is a cell of EMF 2 volt. Now I have to follow sign convention. When I am moving along the direction of a traverse, when I am crossing the cell, I am moving from the negative terminal to the positive terminal of a cell, which means I am moving from a lower potential to a higher potential. That time EMF should be taken as positive according to the sign convention. Correct? So, it should be plus 2 is equal to 0. I will substitute for I3 as I1 plus I2 from the previous equation. Then remaining things 2, 3 plus 5, 8 I1 minus 8 I1 plus 2 is equal to 0, correct? So you can, I think I can skip the steps. You are able to understand. Here 10 I1, here 8 I1. So obviously it is minus 18 I1, minus 18 I1, minus 10 I2, correct? Is equal to, shall I take 2 to the other side? It will become minus 2. You know that mathematically I can change the sign throughout, it is allowed, and I can divide throughout by 2 also. I will divide by 2 and I will change the sign throughout. If I do that, 2 9s 18, 2 5s 10, 2 1s 2. This is one equation. So after applying KVL to a one mesh, I got an equation with the two unknowns I1 and I2. You know, one equation with the two unknowns you can't simplify, which means I need a one more equation with the same two unknowns. To get a one more equation with the same two unknowns, I will apply KVL to a one more mesh. If I apply KVL to a one more mesh, I will select a mesh A, B, E, F, A. A, B, E, F, A. Again, I will skip the steps, you should be able to understand at this stage. A to B, product of IR is minus 10 into I3. Rule is followed. Direction of a current and direction of a traverse are same. A to B I reached. I reached B. I am moving from B to E now. B to E, it is 2 into I2. Product of current is 2 into I2. Again it is minus because direction of a current and direction of a traverse are same. Move from E to F. When you move from E to F, you will come across resistance 2 ohm, current is I2. Obviously it is 2 into I2 minus 2 into I2. The reason is the same. Direction of a current and direction of a traverse are same. Move from F to A. When you move from F to A, the product of current and resistance is again 5 I2. Again it is minus. You know the reason. So I reached back A. Product of IR is over. Now I would refer EMF. A to B, no EMF. B to E, no EMF. E to F, there is a cell having a EMF 1 volt. When I am moving along the direction of a traverse, when I am crossing the cell, don't you think that again you are moving from negative to positive of the cell? Means EMF should be taken as positive. So it is plus 1 is equal to 0, correct? Again, I3 can be replaced as I1 plus I2. This is 2, 4 and 5, 9 I2. Shall I take a 1 to the other side as minus 1? Now I will multiply 10 inside the bracket and simplify. You will get minus 10 I1, correct? Minus 19 I2 is equal to minus 1. Minus 10 I1, minus 10 I2, minus 9 I2 is minus 19 I2, correct? I will change the sign throughout. It will be 10 I1, 19 I2 is equal to 1. I got equation 2. Just look at equation 1 and equation 2. Don't you think these two equations are having the same two unknowns? Simultaneous equation, solve for I1 and I2. So what you can do is, just look at equation 1, it is 9 and here it is 10. I will just multiply equation 1 by 10, equation 1 multiplied by the number 10, then minus equation 2 multiplied by 9. Equation 2 multiplied by 9. My aim is to getting rid of I1. Once you get rid of I1, only one unknown is left at I2. That I will get the answer. Then substitute I2 back in one of the equation, either 1 in or 2. You will get equation. You will get the answer for I1. Then substitute back in this. You will get the answer for I3. Then you can get the answer for the remaining question in the problem. See, when I multiply equation 1 by 10, be quick in understanding. 90 I1, correct? 9 tens are 90 plus 5 tens are 50 I2, right? Is equal to, this is a 10. 10 ones are 10. Then I have to subtract equation 2 after multiplying by 9. First I'll multiply by 9 and write 90 I1. This is 19 into 9 I have to do, right? 9 nines are 81, 8 is remaining, 9 ones are 9, 9 plus 8, 171, correct? Into I2 is equal to 9 ones are 9. I have to subtract, no? Shall I change the sign? When I subtract, the sign will be changed. Don't you think that 90 I1 will get cancelled, and here you are left out with minus 121 I2. I think you are able to follow. Minus 121 I2 is equal to surely 1, which implies I2 is equal to minus 1 by 121 ampere. If you simplify that, it will be equal to minus 0.0083 ampere. That you can do it using a calculator. So substitute that I2 back in any one of the equation, either in equation 1 or equation 2. If I substitute I2 in equation 1, equation 1 is here, 9 into I1 plus 5 into minus of 0.0083, correct, is equal to 1. If you simplify again using a calculator, you can get the answer as 9I1 is equal to, what I am going to do is, this is 9I1, this I will multiply by 5 minus some answer you will get, take it to the other side, you will get some positive answer. That means 1 plus something, that will be equal to 1.0415. 9I1 will be equal to 1.0415. If you simplify that, this I1 will be equal to surely 1.0415 divided by 9. Don't you think that particular part you can simplify using a calculator? It comes around 0.1157 ampere. 0.1157 ampere. See, that means you got the current through the first cell, that is 0.1157 ampere. You got the current through a second cell, that is obviously minus 0.0083 ampere. I told you already, if the current in the branch is not as you indicated, you will get a negative answer, which means I2 is 0.0083 ampere, indicating that current in this branch is not as you indicated, it is opposite. Don't go to change it. Now next one is I3. I3 you can find out by substituting in this equation. You have to substitute in that equation. I3 will be equal to I1 plus I2. You know I1 is 0.1157, correct? You know I2, that is minus 0.0083, right? If you simplify it, the answer will be nearly 1.074, sorry, 0.1074. Just add them. I mean to say, you have to include a negative sign. That is the important thing. That is a common mistake you commit. You ignore the negative sign. With the negative sign, you have to substitute. So when you do that, it will be 0.1074 ampere, that is I3. So you got the answer for the 3 questions, I1, I2, I3. What is left out? Potential drop across 10 ohm. Can't you get the answer for that using the formula I3 into R? Current into resistance, which is I3 is 0.1074 into R is a 10 ohm. You get the answer as 1.074 volt. This is the answer for the last question in the problem. I hope you understood this. So look at one more problem. In the problem already there is a network given. By looking at the diagram you can understand that it is a Wheatstone's network, and you are asked to calculate current through the galvanometer. So what you can understand in this network is, there is a 2 ohm resistor, there is a 3 ohm resistor, there is a 4 ohm resistor, there is a 1 ohm resistor, and here there is a galvanometer of resistance 10 ohm, and across A and C there is a cell of EMF 2 volt and small r is given as 0, means you are asked to ignore the internal resistance of a cell. Ultimately at the end you are asked to calculate current through the galvanometer. First of all you check whether the network is balanced. If the network is balanced, you know current flowing through a galvanometer is 0. Obviously they won't ask such problem for the 5 marks. But just for your information I am telling you, this is comparable to P, this is Q, this is S, this is R. P by Q 2 by 3, R by S 1 by 4, obviously 2 by 3 is not equal to 1 by 4, means network is not balanced. When the network is not balanced, surely there is a current flowing through the galvanometer. That only you are asked to find out. Let us mark current in the various branches in the circuit. So here if I say current is I, as long as it is a single branch, current should be I only, no? Here the current should be I. Why I named the direction like in this direction? Because this is a positive terminal of the cell. current should be sent in that direction. Don't you think A is a node where I will divide into a branches I1 let us say through 2 ohm and I2 through 1 ohm. Assume that B is at higher potential compared to D. So, in that case I1 will divide, one part will flow through a galvanometer, that is IG, and remaining current will has to flow through 3 ohm, it will be I1 minus IG. Now, this IG will add up to I2, together they will flow through 4 ohm, that is surely I2 plus IG, and I2 plus IG and I1 minus IG will add up together, where IG will get cancelled, I1 plus I2 will be nothing but I. This is a well known fact. Now, coming to the question asked, you are asked to find out what is the current flowing through the galvanometer. To answer the current flowing through the galvanometer, you can think of taking a help of KVL. Apply KVL to a mesh A, B, D, A. See, the direction of a traverse was selected in this particular direction. You are applying KVL to the mesh A, B, D, A. When you apply KVL to a mesh A, B, D, A, move from A to B. Product of current and the resistance is 2I1, and according to sign convention it should be minus 2I1, because the direction of a traverse is from A to B. Direction of a current is also from A to B, means product of IR is taken as negative. Move from B to D, resistance is 10, current is IG, again direction of a current is same as direction of a traverse, so product of IR is taken as negative, minus 10 IG, correct? Move from D to A, resistance is 1 ohm, current is I2, 1 into I2 is obviously I2, and this time it is plus I2, because direction of a current is from A to D, direction of a traverse is opposite to it. So, this is one of the equation which I am having now. So, this can be also simplified and written as 2I1 plus 10IG minus I2 is equal to 0. Let this be equation 1. There is no EMF, that you can understand here, there is no EMF. So, obviously the answer will be in this format, it is equation 1. What you notice here is, I am having a one equation with the 3 unknowns. You know, one equation 3 unknowns, you won't be able to find out the answer for those unknowns. When you have a 3 unknowns, minimum I require 3 equations. So, for that reason, I will continue applying KVL. This time I will apply KVL to a mesh BCDB. I will apply KVL to a mesh BCDB. If I apply KVL to a mesh BCDB, again B to C, when you proceed, product of current and the resistance is 3 into I1 minus IG, plus 3 into I1 minus IG, or minus, again minus, because direction of a traverse is from B to C, direction of a current is also from B to C, that is why the product is taken as a negative. Okay, proceed. We'll move from C to D. When you move from C to D, the product of current and the resistance is 4 ohm, current is I2 plus IG, it should be 4 into I2 plus IG. Is it plus 4 into I2 plus IG or minus 4 into I2 plus IG? It should be this time plus, because direction of a traverse is from C to D, the current is from D to C. We'll proceed. When you move from D to B, product of IR is 10 into IG. Is it plus 10 into IG or minus 10? Again it is plus, because direction of a traverse is from D to B, current is from B to D. That should be equal to 0. There is no EMF. So, according to the KVL, that should be equal to 0. Now, if I simplify, this is minus 3I1 plus 3IG, correct? Then plus 4I2, then plus 4IG plus 10IG is equal to 0, or I am having minus 3I1 here, and IG will be 3, 4, 7, 7 plus 10. So, I am having 17 IG, then plus 4 I2 is equal to 0. Let it be equation 2. I think you followed. So, this is the second equation which I am having now. where minus 3 I1 plus 17 IG plus 4 I2, correct? So, equation number 2. Again I am having a 2 equation, but the same 3 unknowns. I already told you, when you have a 3 unknowns, I require a minimum 3 equations to solve. So, in order to get us one more equation, what I will do is, I will apply KVL to a one more mesh. To name the mesh, let us name this particular point as F, this point as G. I will take the mesh as A, D, C, F, G, A. A, D, C, F, G, A in this direction. A, D, C, F, G, A. We will go in the order A to D. What is the product of IR? 1 I2 means I2 plus or minus, minus, because direction of a current and direction of a traverse are same. Then D to C, direction of a traverse is D to C, direction of a current is also from D to C, means again the product of IR is negative, minus of 4 into I2 plus IG, correct? Move from C to F, you do not have a product of IR. Move from F to G, you do not have a product of IR because internal resistance was taken as 0 in the problem, and move from G to A, there is no product of IR. So, product of IR concept is over. Do you find any cell in that mesh? Obviously, one cell is there, its EMF is 2 volt. According to the connections, if I go along the direction of a traverse, I have to cross the cell such a way that I have to move from negative to positive, means E potential is increasing. So, that EMF is taken as positive. What is the EMF given? 2. So, it is plus 2 is equal to 0. I hope you understood this. Now, if I simplify, I am going to get minus 5 I2 minus 4 IG plus 2. I will take it to the other side, it will become minus 2, correct? You know that I can change the sign throughout. If I change the sign throughout, I will get 5 I2 plus 4 IG is equal to 2. Let it be equation 3. Look at equation 1. There are 3 unknowns I1, I2, IG. Look at equation 2. There are 3 unknowns I1, I2, IG. Look at equation 3. There are only 2 unknowns I2 and IG. So, what you can do is, you can think of solving equation 1 and 2, try to get rid of I1 from the equation. When you try to get rid of I1 from the equation, resultant equation will contain I2 and IG. That will take it as equation 4. Now solve 4 and 3, because 4 will contain I2 and IG, 3 also contains I2 and IG. You can get the answer for IG. That is the technique. Of course, we have a different methods, like you can use a Kramer's rule if you are knowing about that matrix and determinants problem. You can use that method, I do not mind, but I will go for the general approach. If some of you may not be knowing the Kramer's rule. So, general approach of solving simultaneous equation is, I will solve 1 and 2. I will try to get rid of I1, means I have to multiply equation 1 by 3. Equation 1 should be multiplied by 3. Then I should add it to, after multiplying equation 2 by 2. Equation 1 is multiplied by 3, equation 2 is multiplied by 3, say 2. I have to add. If I multiply equation 1 by 3, I will get 3 2s is 6, right? 10 3s are 30, right? And this is 3I2 should be equal to 0. Now I am multiplying equation 2 by 2. 3 2s are 6, then 7 2s are 34 IG, correct? And 4 2s are 8 I2 is equal to 0. I have to add. When I am adding, obviously I will get here, this is a 8 I2, this is a 3 I2, correct? I am multiplying equation 1 by 3, sorry, this is minus 3 I2, not plus 3, minus 3 I2, minus is there, minus 3 I2. So, now I am adding the equations. Can I cancel this? What you are left out with? This will be 64 Ig, correct? And this will be plus 5 I2 because 8 plus 8 minus 3 will be plus 5 is equal to 0. Shall I take this as equation number 4? Yeah. Now look at equation 3 and 4. Can't you think of subtracting equation 4 from 3 or 3 from 4? Anything is okay. I can say equation 3 minus equation 4, not a problem. Equation 3 is 5I2 plus 4Ig is equal to 2. Equation 4 is 64Ig, I will write in the order 64Ig, correct? And plus 5I2 is equal to 0. I have to subtract, no? I have to change the sign. I think you are able to follow. Can I cancel this 5I2? If I cancel that 5I2, you are left out with here minus 60Ig, correct, is equal to 2. I hope you followed this. It is minus 60 Ig is equal to 2. So, what is Ig then? Ig will be equal to 2 by 60, right? Equation 3 minus equation 4. Equation 3 is here 5I2 plus 4Ig, correct, is equal to 2 minus 4. If I do that, equation 4 is here 64Ig plus 5I2, 64Ig plus 5I2. This is 5I2 plus 4Ig. I asked you to subtract equation 4 from equation 3. 3 minus 4. 3 is here. 5I2 plus 4Ig is equal to 2. Then 4 is here. 64Ig plus 5I2 is equal to 0. Then I change the sign because I have to subtract. This will get cancelled. Here you will get minus 60Ig is equal to how much? 2. Or Ig will be equal to minus 2 by 60. That is nothing but minus 1 by 30 ampere. You can simplify this. That is the answer for the current flowing through the gallon. You can simplify that. In terms of fractions you can write. Is it clear? I hope you understood this.